Hello everyone. So today we will see how to use GDB to debug a C program. Now what is GDB? GDB is the GNU debugger, especially for debugging C and C++ programs. So we can debug a number of different things which are causing problems in our C program. And in this specific video, we will be debugging a segmentation fault type of error. So first of all, let me show you my GDB version. I'm on Ubuntu Linux and this is my GDB version. By the way, whatever I'm showing you in this video will be probably working on any of the GDB version. It is pretty standard thing. So in this video, what I will do is that I will create a C program test file and I will intentionally make it crash. Okay, all right. So let me create that program. Okay, and just for make it little interesting, I will make a function like this. So the main function will be calling this bar function, and in this bar function I will write a statement which will cause it to crash. Okay, now let me explain you this a little bit. So inside this bar function, I'm creating a pointer to an integer, and currently this pointer is holding null. So null is basically a 0. So this pointer is holding the memory address of 0. It is pointing to 0. And at that memory address which is holding 0, at the 0 address, I'm trying to store 9. So definitely this will cause a crash because address 0 is not accessible. It is prohibited to store something there. So this statement will cause this whole program to crash. Okay, all right. And the particular crash will be this segmentation fault. So now I will save this and I will run this. So I will use GCC to compile, and the output file I will keep it as app and I will press enter. Okay, I have compiled this test.c and the output binary that I have obtained is app. Now I will try to run this. So /app app. Okay, so when I try to run this, it crashed, and the specific crash is segmentation fault. So what is segmentation fault? It is an error when we try to access some invalid memory address. As I showed you that when I was doing *ptr equal to, let me add this statement, *ptr equal to 9, at the 0 memory address I was trying to store the value 9 at that location. So this caused the invalid access of memory and the whole program crashed. And what is this core dump? So core dump is also a file that can be generated. Right now it is not generated, but it can be generated, that holds all the information about the memory and CPU also at the time of the crash. So we will also look later when we will be doing system programming and related videos. I will show you how you can also debug using core dump. But in this video, we will, since we directly have this source code test.c, directly we have it with ourselves, we will debug it using this test.c file, and for that we will be using GDB. So why is this core dump anyway useful at all? So when it is useful is that, suppose your program, your C code is, for example, running on a server. There you don't have access directly on that server, and later your C file crashed on that server. So it will generate the core file there, and later you can inspect the core file to find out the reason for the crash. Okay, this is the whole point of this core file, core dump. We will see, we will have a very deep look at this core dump thing. But for now, let's get back to where we are. So we are directly having access to this test file. So why should we bother about this core dump? We will directly debug using this. Okay, now I am opening GDB. So here with this GDB, after that you have to specify the name of the binary. It is important, not the name of the your C code, not the source file, but you have to specify the name of the binary, which is app. So app app, and I will press enter. Okay, so what this does is that this loads the app binary into GDB. So GDB loads this app. It is not running the app, it has just loaded it. The app has not yet started running. And one statement that we can see is that no debug symbols found in app. So GDB was unable to find debugging symbols in this app binary. So this is important because without the debugging symbols, we can, I mean, intuitively feel that we will have problem in debugging. It will not show extra information or useful information while debugging. So but anyways, let's try, let's move ahead. So here I have this GDB prompt, and here I can type GDB commands. So if I will type the command run run, it will now start running this binary. Okay, by this command it had just loaded the binary, but if I will type run command here, it will start running this binary inside the GDB. And the specific error that we were debugging, this segmentation fault, there is one, the special thing about this type of error is that when the GDB starts running the app or the binary which has segmentation fault type of error, it automatically stops at that place. Okay, the GDB, and wherever it stops, so we get to know that location, and so we can zero in on the place or the location. But since there is no debugging symbols in this app binary, it will still be difficult. We will see just now. So I will type run to run this binary. Now it will actually execute this app. Okay, now I will press enter. So again it has stopped at this location. In bar, at least it has showed us this name of the function that caused the crash. Let me open another tab in which I will open this test case. So this was the function, and this was the problematic statement which caused the program crash. So at least it has, this GDB has shown in output the name of the function that is causing the problem. And above that we can see that program received signal 6 segway. So this is the signal that is sent, and this represents segmentation fault. So basically, in easy words, it says that we are trying to access some invalid memory address. So usually, I mean, at a lower level, at the kernel level, what happens is that the page fault happens before the segmentation fault. Okay, with the page fault, it tries to access, if the memory is not present, it tries to search the memory, and even after the page fault, if it is not able to find the memory, then the segmentation fault happens. But this is just an extra information which is not needed actually for this debugging. So let's move further. So at least we have reached the place which is causing the program crash. But especially in the segmentation fault type of errors, we usually want to see the backtrace. So for the backtrace, we type bt here and press enter. So what is backtrace? Backtrace tells us all the function calls that happened. It shows us the flow. So of course it started from the main, then the flow moved to the function bar, and at somewhere inside the function bar we got the segmentation fault. So usually in the segmentation fault of error, you will initially run the binary, and then at somewhere you will type bt for backtrace, okay, to see the flow. So now again I am emphasizing that because of this no debugging symbols found in app, there is no useful information. Of course there is some amount of information, but not much debug information that we can see. All because of this, because we compiled our C code directly using GCC. We never told GCC to add debug symbols inside this binary. Okay, to add debug symbols, what we have to do is that we have to add -g option or the -g option. Okay, so now I will exit out of this GDB and I will build it again, my test C code. This time I have a specified -g option. This tells us to add the debugging symbols. So whenever you want to debug it, you need to add -g option. And of course this is only for debug builds. For release binaries that you want to release into production, of course you will never want to do this thing. You would never want to add debug symbols because someone else can debug your binary. This is only for debugging when you are in development phase. And the output file name, the name of the binary, I will name it as new. Okay, so I press enter. So I have now this new binary, and if we will see that this new binary has somewhat bigger in size than the old app binary, and of course we can easily guess why is it bigger, because this new binary contains debugging symbols. Now we will exploit the debugging symbols in the GDB during debugging to exactly get to know the reason of the program crash. Okay, so now let me load this new binary, new and I will press enter. Okay, now again we can see this statement has changed. It is now reading symbols from this new binary. Earlier it was unable to find debugging symbols, but now it has read successfully the symbols from this new binary. So we can expect some more useful information out from the GDB during debugging. We will see just now. So again I will type run to run this binary, because we know we are getting segmentation fault, so GDB will automatically take us to the location of the segmentation fault and it will stop there. Okay, and after typing run I will press enter. Okay, here, so it has taken us to this function again, bar, but now it is giving us extra information, like in this test.c line number 7. So at line number 7, again here line number 7, this is the statement which is causing the segmentation fault or the program crash. So again, if we will compare at the earlier with the earlier way that we debugged, it was not showing any statement or line number. Okay, because earlier this app was not built using the debugging symbols. So again back to where we were. So now we have reached the location of the exact statement which is causing the crash. We can try to see the value, that what is in fact inside PTR. Okay, so to check the value inside any variable inside GDB, what we have to do is that we have to write print and the name of the identifier. Okay, so PTR, and let's press enter. So again it says 00 and int pointer. So we can clearly see that because the PTR is holding the 0 value, and at the 0 memory address we are putting the value of 9, so it is a very bad thing to do, and that is why it is causing segmentation fault. Okay, and even since right now, since it has debugging symbols, we can easily see the line number that we are here at line number 7. We can even open the source code in the other tab and look at the exact statement, that this is the statement which is causing the problem, and we can see the other some statements above and below and try to find out the reason, try to guess the reason of crash. So now since we have found out the reason, exact reason of the crash, because the pointer was holding the null address and that was the reason, we can take some remedial actions. Now I will quit from the GDB, because the GDB has helped us to find out the exact location of the crash. We can easily go to the file and change the C code. And by the way, let me run it again. So we were here. Okay, and usually in this segmentation fault type of errors, you would want to do bt backtrace again, and this shows the call stack. So first the main function was called, then at the line number 14 it again called this bar function. So at this is the line number 14. Okay, as we can see here, line number 14, it called this function bar. Okay, so it is again showing the line number or useful debugging information. So all this because this time we compiled this C code using the -g-g option. So it added the debugging symbols into this new binary, and because of all these debugging symbols we are getting these line numbers and these statements and all. Okay, so I will quit, and now if I go to this code and this is a very standard thing. Basically, if you are using any pointer, then you should check that if that pointer is valid. Okay, so here first I check that if the this condition will be true only if there is some non-zero value in this PTR. Okay, so right now, because PTR is null, this will be false and this statement will not get executed. Okay, so in the case of pointers, we should definitely take care what it is holding. Okay, so this is a check that I have applied. Now I will compile this once again. Okay, now since I have already modified the code and I know this will be working, so right now I will not be debugging this. I am just compiling this straight away, and now I will run app2, and so it has run fine without any problem. So we can see that to debug, so the whole to summarize, the whole point is, if we are trying to debug our source code, then we should add the -g option with the GCC while compiling. And when we open that binary, that compiled binary which is holding the debugging symbols with the GDB, then we have to run that binary. So by to run the binary, we have to type the run command in the GDB prompt, and the GDB takes us to the location that is causing the program crash, which is the segmentation fault in this case. And there we get all types of useful information, and further we can do BT backtrace to get all the call stack, which basically tells us the whole flow of the program. So first main was called, then bar, and like this. So I hope this video was useful, and thank you for watching.